about to go through this stuff, you should have no problem at all. Same as the other two tests. This is 5 problems. The reason we're doing it like that, same as the last test, is that it's not a matter of just being able to Google the answer. You got to be able to think about what we're doing and talk a little bit about what we're doing. Okay. This test is all about the atom. So we first need to understand how the atom's set up, talk a little bit about the history of the atom, then we'll get into electron configuration, atomic designation, and things like that. There's one more thing on the test that we didn't get to last week that is, I thought about, I was like, do I need to leave that question or do I need to keep it up there? And I chose to keep it up there because it's so stinking easy, and it's half-life, okay? So we talk about protons, neutrons, electrons. Protons tell you what you are. Electrons tell you how you act. Neutrons keep you stable, okay? So we didn't really get into the whole neutrons keep you stable very much. These big giant atoms on the bottom of the periodic table, like uranium and plutonium and americium and things like that, they're radioactive. And what that means is they're not stable, and the electrons just straight up fall apart, or the atoms just straight up fall apart because they're so big they can't hold themselves together. That's called radioactivity. Now, what's neat about radioactivity is it happens at a steady pace. And how they measure that pace is called the half-life. So half-life is exactly what it sounds like. It's the time it takes for half of an atom to degrade. Half of an atom, half of a material to go away. So let me show you an example of that. So this is a measure of time. And that E is supposed to be up there. I might have to straighten this up real quick. Sorry, guys. So it's a measure of time. It's the time it takes for half of the substance to degrade. Whatever. Really? Board's been working really good. Right, so for example, let's say uranium has a half-life, or let's say an unknown substance. An unknown substance has a half-life of 10 years. So if the half-life is 10 years, and let's say you start off, I'm gonna have to get this straight, guys, sorry. You start off with 100 grams, okay? After 10 years, how much are you gonna have? 50 grams. So one half-life, you're gonna have 50 grams. What about 20 years? 25. Everybody cool? So instead of losing 50, you lose another half. You have 25 grams. And in another 10 years, 30 years, you'd have half of 25 is 12.5. Okay? And you just keep on going down. And you just keep losing half over and over and over again. Half-life is a pretty easy thing to understand. It's just a matter of taking your total years, dividing it by how many half-lives you have, and then dividing by 2 each time. I'll do another example of that before we leave today, but I just wanted to real quick throw that one out there. Questions? All right. Let's switch gears. Let's try to straighten this up again. Sorry about that. All right, maybe if I use my pen, it'll work better. Bang. Bang. Let's see. All right, so let's talk about the things in the atom. What are the 3 big things, 3 big important things?
Electrons, neutrons,
Electrons, neutrons, and protons. Okay. Which of the what up there are in the nucleus? Protons and neutrons. These guys right here are both located in the nucleus, whereas electrons are where? Surrounding the nucleus, flying all over the place. Okay. right, what about charge? Talk about alliteration. Blanks are positive.
Protons are positive.
Protons are positive. Alliteration. Protons are positive. Protons are positive. But then the negative one isn't so much of an alliteration.
It's neutral.
What's neutral?
Neutrons are
Neutrons are neutral. Electrons are
negative.
negative. These guys are negative. Neutrons are neutral. So when you're talking about the charge, I don't care about neutrons because they're zeros all day long. Okay? Protons and neutrons are in the nucleus. Protons are positive. Electrons are negative. Last thing we need to talk about is mass. Where is all your mass of your atom? Yeah, y'all told me. I heard it.
Protons, electrons. No,
Not electrons.
neutrons added up.
The protons and the neutrons are your mass. They're both in the nucleus. If you watch the video on the history of the atom, one of the things we talked about is Ernest Rutherford. Ernest Rutherford did something called the gold foil experiment, where he shot atoms as they went through gold foil, and the atoms just went through the gold foil because most of the atom is empty space. Most of the atom is empty space. All of the mass is that tiny little nucleus in the middle. Protons and neutrons, that's where you get your mass. Protons plus neutrons. That gives you your mass. Electrons have mass, they're just so small, you don't really care. So you got to test the question tomorrow that asks you to explain the structure of the atom. Describe the structure of the atom. So you're going to want to mention all three of those three things: protons, electrons, and neutrons. You're going to want to make sure you tell me protons and neutrons are in the nucleus. And you're going to want to tell me protons and neutrons are what gives you mass. And then you want to tell me about the charge. Protons are positive, electrons are negative. Questions on structure? And I'm going to post this video this afternoon if you want to rewatch this tonight as we go through it. Okay? So that's one question down. Describe the structure. And kind of along with that is the question about how the atomic model changed. Okay? If you haven't done the Jamboard activity, let me bring it up for you. If you haven't done the Jamboard activity, I strongly suggest that you do it. It's pretty straightforward. All you have to do is watch the video. And I think the video is actually linked. Yep. The video is linked. So hit your module, go to this module. It's like last week's module. The assignment's called History of the Atom. And if you click, make a copy of this Jamboard, and bring up right here, these three dots in the right corner, make a copy for yourself. And then what you're going to do, it says do not move the titles. You got 6 titles. And all you have to do is put each of these things where they go. The easiest way to do that is to hear me talk about it. And actually during the video here, if you click on the link of the video, actually go to the Jamboard and show stuff kind of where it goes. So if you watch that video, you got a short question that says, describe the history of the atom. Big things I'm looking for: Democritus and Bohr, your beginning theories of the atom, talked about the word atomos. Democritus called it atomos because he thought you reached a point for an atom where you couldn't get any smaller. He used the word indivisible. Where do we use the word indivisible every day? Very good. You say the Pledge of Allegiance, you say indivisible because the United States is indivisible. You cannot divide it. An atom, both Bohr and Democritus thought that you couldn't get smaller than an atom. And so their model, these guys right here, these solid spheres. Whereas later on, you had discovery of other things, and you got to check that out. The plum pudding model, there it is. The little nut, the nucleus, the orbital model looking like planets, and the electron cloud model, which is our modern theory. I'm not looking for a page essay on history of the atom. I'm looking for big picture stuff. They thought it was indivisible, and then they discovered subatomic particles, electrons, then they discovered the nucleus, and then electrons can have energy. If you give me all of that, you're gonna have probably extra points on the test, okay? Answer the question, don't stress out about giving me too much, okay? Or not enough, really, to be honest with you. All right, do you have a half-life question? I'll do another one of those before we cut the video off today. And then the other two questions are electron, or atomic designation and electron configuration. So the atomic designation question is just like the ones that we did in class, where I gave you an atomic designation and you tell me protons, neutrons, and electrons. So let's do an example of that. Come on, mouse. All right, so let's do two examples of that. Say we have tellurium and let's say we have aluminum. Right? Which is the easiest one up there? Protons, neutrons, electrons. Everybody with me?
Protons.
Protons are always super easy because it's always your atomic number and it can never change. Look at bottom left, exactly. Look at aluminum. What number goes with aluminum?
13.
And then what number did I put up with there with aluminum?
13.
How many protons you got?
13.
13. 13 protons. How about tellurium?
52.
Piece of cake? There it is right there. If you didn't remember right there, look up tellurium over there. It's all the way to the right almost. TE 52. The other two are a little bit more complicated, but not really that hard. What's this number here? The what number?
The mass number.
The mass. On the previous page, I said blank plus blank equals mass.
Protons.
Protons and neutrons. All right. So I have one, I just need the other. 52
70.
plus what is 122?
70.
Everybody see how he, yes ma'am? 122 and 52, the difference is 7. No, okay, you do add, but you add to get that. So 50, so like if you set it up like a like an algebra problem, it's 52 plus x equals 122. Because you add the protons and the neutrons together, I don't know what the neutrons are, I just know the answer is going to be 122. Does that make sense? So if you want to think of it, instead of thinking of adding, thinking of just subtract. You with me? So neutrons will be over there. Very good. 27 minus 13, you got 14 neutrons. And then lastly is electrons. Electrons, I don't like saying anything about a rule about adding or subtracting with electrons. I like just asking two questions. Do I have more protons than electrons? And how many more? So the first question is, am I positive or negative? Because positive means you have more protons and negative means you have more electrons. Looking at the first one, am I positive or negative?
Negative.
It means I have more
With electrons.
electrons. So this number needs to be what than this number?
Larger.
How many big? How many?
2.
What's the answer?
54.
Very good. Don't think about adding or subtracting. Don't make yourself a rule. You'll get confused. Negative means I have more electrons. How many more? 2 more. What number is 2 more than 52? 54. And you'll never have, this number will never be too big. The most you'll ever get that number being is 5 or 6. So that's why I say don't make it a math problem. Just make it a common sense problem. Okay? Positive 3 means you have more protons. So this number is going to be bigger or smaller?
Same.
The only way it would be the same if it was 0. There's plus 3 there. Plus means I have more protons, so this number is going to be bigger. You with me? Okay, 13 is 3 bigger than rock and roll. That's all you got to do. Feeling good? Take your time. Luckily, you guys in the room are all here tomorrow, so I can work over your shoulder with you and I can help guide you through it. Don't do like my students last period and just hit enter and submit their test without asking a question. Speak up, ask questions. I'm there for you. I want to learn. I want to get it right. Everybody good? All right, the last thing we have is electron configuration. Now, how your electron configuration on your test is going to be tomorrow is I'm going to give you an electron configuration, and I'm going to ask you what is wrong with this electron configuration. Okay? So let me give you an example. I'm going to write the electron configuration for nitrogen. There are 1, 2 big things wrong with what I just did. So how do we do electron configuration? You read the periodic table. So when I'm reading the periodic table, you always start on what row?
The top.
The top, which is what row?
The hydrogen helium.
1.
1.
Everybody good? So did I start on 1? Did I do that right?
Yeah.
Okay, so that's good. Then we always count through the blocks. You need to know your letters. This is just something you got to know. You can use the periodic table on the internet. It'll help you if you forget it. This right here is always S. This right here is always P. And this in the middle is D. This is F, but we don't need to know that. S, P, D. So I started on 1. I'm going to start all the way on the left, which is what letter? I just told you. S. Did I start with 1S? So that's good. Now I had to go all the way through that first row. How many elements are on the first row?
2.
Did I give you 2 elements? I said 1S, 1. So there's my first mistake, right? Instead of 1S1, I should have written 1S2. Okay? Let's keep on going. Once we're done with that first row, we go to the second row. Did I go to the second row? Then we go all the way to the left. What shape? Or what letter? S. Did I go to S? And then we're going to count all the way through it. 2S, bam, bam. How many? 2. Did I say 2S2? Is there anything wrong with my middle thing? So we keep on rolling. Next, I'm going to go to the P block. What row am I on?
You're on the
Say it loud.
3.
Did I go to the third row yet?
No, second row.
I'm still in the second row. What did I write on the board?
You went to the third row.
Tell me what's wrong.
It should be 2 instead of 3.
It should be 2 instead of 3. So instead of writing 3P3, it should have been 2P3. So the correct way to write this would be 1S2, 2S2, 2P3. Rock and roll?
You do one more now.
Sure. Let's go big. Let's do arsenic. AS.
33.
Okay, so I'm gonna write it out and I'm gonna make 3 mistakes.
All right.
I'm gonna make 3 mistakes, see if you can figure out what they are. Trying to get that out of my way. You can find my 3 mistakes. Let me double check, make sure I made 3 mistakes. 1, 2, 3. Yep, 3 mistakes. Give everybody a chance to look at it. There's 2 mistakes that should be pretty easy to find. 1 mistake that you have to remember some things we talked about last week about. Let everybody get a chance to check it out. All right, go ahead, Josh. You want to tell me one?
For when you got to the other side of the second row, you put 5 instead of 6.
Very good. If I count it all the way through the P block, look how wide the P block is. B, C, N, O, F, N, E. Your P that you, unless you're stopping in it, the P block should always be 6. Somebody different. This is one of the mistakes, Martin, you told me earlier.
4D.
Wow.
Must be 3D.
Very good. D is weird. If you're on the 4th row in the D block, you go 1 behind. So instead of 4D, it should be 3D. Okay? And there's one more mistake.
Is it 3P6?
Nah, I got 3P6. That's perfect.
You have 3S2, and don't you have to include the D? You can't get the D without getting that.
No, I can't on the 3rd row.
Oh, okay.
Good try. All right, so let's follow along with it. 1S2, that's good, right? 2S2, that's good. 2P6, bam, loving it. 3S2, 3P6. Martin was just telling us that's good. Next row, 4S2. So we're on the 4th row, right? 3D10 because the 4th row should be D, and then
it's not 5P3, it's 4P3.
You don't skip to the 5th row, you're still on the 4th row. Same thing tomorrow. I'm here for you. I'll talk it out with you. Don't just sit there being stuck. If you haven't, I got a bunch of folks in here I know who haven't done the electron configuration practice and videos. So I would strongly suggest you do that in the rest of the class time we have today. If you need headphones, I think I might be able to dig out some for what we have for my folks that do need headphones. Okay? That's what we got tomorrow, guys. Half-life question, which I'll do another example. Tell me about the atom. Tell me your protons, neutrons, electrons. Do an atomic designation where you have to be able to figure out how many protons, neutrons, electrons. Tell me something wrong with electron configuration like we just did. And then give me a little bit of discussion about the history of the atom. Really what I'm looking for is, folks used to think it was indivisible. Then they discovered the first subatomic particle. Anybody remember what it was? The plum pudding model. The electron. Then they discovered the nucleus. And then if you want to say something about energy of electrons, you can say that. Okay? All right. I promised you another example of half-life. Let's try another example of half-life real quick. All right, so let's say you have something has a half-life of 15 years. And right right now you have 60 grams of it. All right. I want to know how much you're going to have after 60 years. After 60 years, how much would you have left? Let everybody get a chance to work on this on your own. You got a question about it or answer? Let everybody get a chance to look at it. So the half-life is 15 years. If I have 60 grams of something, after 60 years, how much do I have left? Ready? All right, first thing I got to figure out is how many half-lives have passed. So I'm going to say 60 divided by not 4. The answer is 4. 60 divided by 15. You with me? 60 divided by 15 is 4. So there's 4 half-lives have passed. Now, how I do this math, you can do it a different way if you want to. But how I do it is I just straight up do it on my fingers. I got 4 half-lives, and so I need to cut it in half 4 times. So first off, 60 is going to cut it in half 1 time, which makes it 30, 15, 7.5, 3 and 3.75. Rock and roll. 3.75 grams is what I have. If you have trouble with that math, holler for me tomorrow. Because this ain't math class. I want you to be able to know how to do it. And I'll have the Zoom up tomorrow if you have questions at home. I want you to be able to know how to do it. And if you have trouble with math and need help with the math, I'm here for you. Everybody cool? Questions? All right, I'm shutting down the Zoom, and then I'll help anybody that's got stuff in the room.